Hey guys, welcome back to another video, and today we'll be discussing about Dijkstra's algorithm. So it is an short algorithm for finding the shortest path between two nodes in a graph. So between all the nodes in a graph. So it is similar to Prim's algorithm. However, in Prim's we'll be looking at like the distances of or the weights of each edge. In this case, we'll be finding the cost from one node to another, and then looking at the adjacent nodes and then comparing. So let's just get into the simulation so it's easier to understand. So here A is our starting node. Okay, so initially everything, like the distance from A to anywhere else, is infinity because we still haven't traversed the whole thing yet. But when we start traversing, that values would be different than infinity. So let's start with A. So A being our starting node. From A we can go to three places, right? So D, C and B. Among these three, which one is the smallest? So let's write these down first. So from A we can go to B, so the band would be A again. So from to C, that would be 4, the band would be A. From A to D, so 7, the band would be A. Among these three, which one is the smallest? Of course 3 is the smallest, so we are gonna pick this one as our path. From this we have gone from A to B, so B is our current node now. So from B we can go to two places, so it's C and F. So remember in Prims, I told you before, like Prims, we have to consider only the distances and then compare and take the smallest one. But here we are going to add up all the costs together. So here from B we can reach to C using, the cost would be 1, and from B to F that cost would be 3. However, we have to come to B, then we can go to all the other places, right? So we have to take in consideration of the cost of this whole path, right? So this is 3, and to go to C we need 1, so that total would be 4. So let's write that down. And from B to C, that would be 4, and from B to F that would be 336 B. So among these, like 4, 7 and 6, which one is the smallest? So 4B is the smallest, so we're gonna pick this path. Now we have reached C. So from C we can go to D and F. So let's write the distances down. So from C to D, that would be 3 plus 1, which is 4, plus 2, that would be 6. So 6 C, because C is the parent, and to go to F we need 10. However, so 10 is much larger than the value that we already had here. So we already had 6, which we can go from B. However, now we have 10, which we can go from C, so we are gonna take the smallest path, of course. So we are not going to write 10C here. So among all of the unhighlighted ones, which one is the smallest? So both have like the same distance, so picking any one of them is okay. So let's try to follow a pattern here, like alphabetical pattern. So we are gonna pick this one. So we have reached D using the path C. So this is the path we have taken. We have reached D. From D, where can we go? We can go to G. We can go to G. We can go to E. So let's write their cost down. So it would be 6 plus 6, that would be 12. So we have 12 D, and to reach E, that would be 6 plus 3, 9. So 9E. Okay, so among these, like the unhighlighted ones, which one is the smallest? Of course 6B is the smallest, so we're gonna pick this path and reach F. So we've reached F, right? So from F we can go to which nodes? We can go to here to E, and we can go to H, and we can go back to C, but we have already reached C, like it's already visited, so there's no point in going there. So from F to E, which would be 7F, so see here, we already had 9, but we have discovered another path which is much cost efficient. So 9, and this one is 7, so which is much better, so we write that down. And to H, that would be 6 and 8 is 14, so write this down. So we can reach H from F. So from this, which one is the smallest? Of course 7F is the smallest, so we take this path and reach E. From E we can go to G and H. So let's write their cost down. So 7 and 3, that would be 10. So 10E. See, 10E is much efficient than 12D, so this is good. And from E we can go to H, which is 7 and a 4 is 11. So again, this is much better from what we already had. So now among these, which one is the smallest? Of course 10E is the smallest, so we are going to G from E. So from G we can go to only one place, that is H, which is not visited yet. So that would be, so we are now at G. From G going to H would be 12, but we are not going to write 12 because that's not efficient enough, because that would be like 12G, but we already have 11E, which is much better, so we are not going to write that down, and we are going to use 11E. So we are going to H from E. So G hasn't actually done anything here, so the row of G is empty, and we have reached H. And from H we can't like go anywhere else, because no other paths are no other nodes are unvisited, so that's why there's no point in finding out all the edges, and we already don't have anything to work with. So see, we have actually reached like our goal, which is finding the shortest path to each node. So let's write that down, the whole path that we have taken. So this is the whole path that we have constructed, and this is the shortest path to reach any node. Now if you want to reach, let's say, E, you have to take the path, so from A to B, so you have to reach E, right? So let's look at the whole table that we have created. So from E we have to go back to 7F, so we go back to F. From F we go back to B, and from B we reach A. So A to B, B to F, F to E. So this is the whole path. So hope you guys did understand what it is. Here's the algorithm that was given in our lab, and there are other easier algorithms, like the theme is same but the writing patterns are different. So and you can have like look at the code online and try the code for yourself. And hope you guys did enjoy the whole video and did understand something. And if you have any comments or suggestions, or just want to say hello, you can do that in the comment below. Thank you.